Okay, so good day everyone. So today we will be solving homogeneous DE or differential equation problem samples. So here are the examples that we will solve later on this video. Let's start with our first example. So first we have here negative y dx plus x plus square root of xy dy equals 0. First, let us determine if it is really a homogeneous differential equation. So this term, the degree of this term is 1. Same as with this term, the degree is 1. And this term has two variables with 1 and 1. So cumulatively, they have 2 as their degree. And since we have our square root, so it means that the degree of the whole term is 1. So it means this is a homogeneous differential equation. Okay? So since this is a homogeneous differential equation, so we will check if which of the following terms are least complex. So in this term, the least complex is the coefficient of the differential x. So it means we will substitute x equals vy. Therefore, your dx would be equal to v dy plus y dv. Okay, then we substitute. That would be negative y. Differential of x, that would be v dy plus y dv. Plus, we have vy plus square root of v y dy equals 0. Let us simplify and distribute. So this term would be negative vy dy minus y squared dv plus vy dy plus, okay? So I could actually factor out your y squared, okay? So the square root of y squared here is y square root of v dy equals 0. And with this term, we can combine or eliminate this vy dy. And we have our simplified term would be negative y squared dv plus y square root of v dy equals 0. And as we can see, this is now a variable separable differential equation. So with this, we can multiply the whole equation by, okay, let's check this first. So since this is a differential v, it means we only need v here as its coefficient. So it means we will divide y squared. It is also okay if you divide negative y squared again. It Basta it does not affect the equation. If you divide negative, you must divide it all throughout the terms in the equation. If you divide the positive y squared, you must divide also to the whole equation. Then we have here the differential of y. So we need only y as our variable in the coefficient. So it means we also divide your square root of v. So our resulting term would be negative dv over square root of v plus y over y squared dy equals 0. Then we can now integrate. So for this term, that would be negative. We will make this as our exponent. That would be v raised to negative 1/2 plus, okay, simplify this one. This would be dy over y equals integral of 0. So let's perform the integration. That would be negative v raised to negative 1/2 plus 1 over negative 1/2 plus 1. Okay? Then plus this would be ln of y equals c. Okay, simplify. This would be, so negative 1/2 plus 1 is 1/2. Okay, so that would be equal to, so negative 1 divided by 1/2, that would be, let's simplify first the coefficient. That would be negative 2. So negative 2 square root of v plus ln of y equals c. But initially, we substituted x equals vy. So it means your v here would be equal to x over y. Okay? So since v is equal to x over y, that would be negative 2 square root of x over y plus ln of y equals c. So that is our final answer. Again, our solution is in its implicit form. We cannot extract, no, or isolate y here. So this is our final answer. Okay, next. Let's have our example number 2. So our example number 2 would be x dx plus y minus 2x dy equals 0. So again, let's check if it is really a homogeneous differential equation. So this term, the degree is 1. Another term, the degree is 1. And also this term, the degree is 1. So this is a homogeneous differential equation. So since we are looking for the least complex, so the coefficient of dx is the least complex here. So it means we substitute x equals vy. And eventually, your dx would be equal to v dy plus y dv. Okay, so we substitute. Okay, that would be vy multiplied to v dy plus y dv plus y minus 2 vy. dy equals 0. Then distribute. This would be v squared y dy plus vy squared dv plus y dy minus 2vy dy equals 0. Okay, so let's check if there are terms that we could combine or eliminate. So with this type of differential equation, we cannot combine or eliminate some of the terms. So it means we just group the differentials, okay? So first, we group the differential v. No? We only have vy squared dv. Next, we group all the terms containing dy. That would be plus, okay? Let's put first the v squared. That would be v squared y. And next, we put the one with negative 2v. And lastly, plus y dy equals 0. So this time, we could factor out your y here. And we are left with v squared minus 2v plus 1. So at this point, our differential equation is now a variable separable differential equation. So in order to separate, since this is dv, so we need to divide your y squared. Next, for dy, we need to divide your v squared minus 2v plus 1. Okay, so we are left with v. This would be over v squared minus 2v plus 1 dv, okay, plus this would be y over y squared dy equals 0. And we could now integrate. Okay, so at first glance, actually, we can look at the first integral here. So let's check if there are factors for the denominator. Okay, let's check if there are factors. Yes, no, there are factors in the denominator here. 1, -2, and 1. So the factors are actually, okay, so v minus 1, that is quantity squared. V minus 1, that is quantity squared. dv plus, okay, this would be dy over y equals integral of 0. So again, our goal here is to eliminate one of the denominators. So we will use the plus minus rule. Okay. So again, if you have any techniques in to solve this integration form, you can use actually. Actually, I could think of a lot of solutions for this. Actually, you can use ln, okay, or natural log, because as what you can see, the denominator is quadratic and the numerator is linear. Okay, so you could use ln. Next, actually, like this one, you could use your partial fraction. Okay, but okay, what I would use here is your plus minus technique, so that we could save some time. Okay, so if you have some time, you can use some of these integral techniques. Okay, so how can we use the plus minus technique here? So that would be okay. So that would be integral of a v minus 1, okay, plus 1 over v minus 1 squared plus integral of, that would be dy over y equals integral of 0. So for this one, we can group your v minus 1 over v minus 1 squared dv and extract the other one, okay, over v minus 1 squared dv plus integral of dy over y equals integral of 0. So for this, we can eliminate one of the v minus 1 and we are left with dv over v minus 1. For this one, we can use your power rule. That would be -2. Okay, dy over y equals integral of 0. So our answer here would be ln of v minus 1 plus, that would be v minus 1 raised to -2 plus 1 over -2 plus 1, which is -1, plus ln of y equals c. So simplify further, that would be v minus 1 plus, or rather minus, that would be 1 over v minus 1 plus ln of y equals c. And we substitute back our v, which is x over y. So our v is x over y. Substitute it to the equation. That would be ln of x over y minus 1. Okay? Minus 1 over x over y minus 1. Okay? Plus ln of y equals c. Again, the solution is an implicit solution, so it means we could not isolate y anymore. Okay? So this is our general solution. That is our final answer. Okay, next. Next example. We have number 3. That would be dy, derivative of y with respect to x equals y minus x over y plus x. Okay, so let's have this one. First, we cross multiply. That would be y plus x dy equals y minus x dx. Again, what I would want to do is to put the dx first. So it means this would be y minus x dx minus y plus x dy equals 0. Okay. So I have another technique here to make this simpler. So again, if you do not multiply the whole equation with -1, it is okay. We will arrive with the same answer. So it is okay if you don't multiply -1, but in this case, I will multiply -1 to make our equation simpler so that I could put it in this way. That would be x minus y. Okay, again, I exchange their signs because I distributed a -1, and this would become positive. Okay, again, I would put x first equals 0. So the question is, okay, is it homogeneous? Yes, of course, no? This term has 1 as its degree, also 1, 1, and 1. Okay, so this is a homogeneous differential equation. Next, I will find first which of the following is the least complex. So actually, based on this, we have two terms each on the coefficients of the differentials. So, in the concept of the least complex, both coefficients have two terms. So you can have either of the two. Okay? So you can have x, you can use substitution, x equals vy, or you can use substitution, y equals vx. It will not matter because you have two terms on each of the coefficients. So in this solution, I will solve on the two, no? Alternate solutions. Okay. So if we substitute x, that would be dx equals v dy plus y dv. Substitute, that would be vy minus y. Then your dx is v dy plus y dv plus, this would be vy plus y dy equals 0. Okay, distribute using FOIL method. That would be v squared y. Okay, that is our first term here, dy. Next, that would be vy squared dv. Next would be negative vy dy and a negative y squared dv. And we have here vy dy plus y dy equals 0. So let's check if there are terms that we could combine or eliminate. So you have this one. Then we group all the terms with bv. We have here vy squared and minus y squared dv. We also group all the terms with a dy. That would be v squared y plus y dy equals 0. Factor out y squared, that would be v minus 1. Also factor out y, that would be v squared plus 1. Then this term or this differential equation is now variable separable. So it means we will multiply the whole equation with 1 over, that would be y squared and v squared plus 1. So our resulting term would be v minus 1 over v squared plus 1 dv. Okay, that is our first term. Our second term would be y over y squared equals 0. Integrate. We could use or we could regroup the following. Okay. That would be v over v squared plus 1. So again, I separated your v here so that later on, I can use your ln. Then minus dv over v squared plus 1. This would be arctan. And for y, that would be dy over y equals integral of 0. Then here, I will let u is equal to v squared plus 1, and your du would be 2v dv. And eventually, your v dv would be du over 2. So this would be, the first term would be du over 2 over u minus, okay, that would be dv over v squared plus 1 plus dy over y equals integral of 0. Then this would be 1 half ln of, okay, our u here is v squared plus 1 minus, this is arctan again, that would be 1 over a, so 1 over 1 arctan u over a, that would be arctan v, plus ln y equals c. But again, we will substitute back our v, that would be x over y. So our final answer is 1 half ln x squared over y squared plus 1 minus arctan of x over y plus ln of y equals c. So that is our final answer. Okay, how about if I substitute here y equals vx? So let's also have that as our solution. So that would be dy equals v dx plus x dv. Substitute. That would be x minus vx. Then dx plus x plus vx. That would be v dx plus x dv equals 0. Distribute. Okay, I'll put a barrier here. Distribute, that would be x dx minus vx dx plus, okay, FOIL method, vx dx, okay, x squared dv, v squared x dx, and lastly, we have vx squared dv equals 0. So are there any terms that we could combine or eliminate? Yes, we have this one. Next, we group all the terms containing v, or dv rather. So that would be x squared. And another is plus vx squared. That would be for dv. How about for dx? We have 2 plus, no? We have here x plus v squared x dx equals 0. Okay. Then we could factor out x squared here. That would be, okay, I'll just put it as v plus 1 so that we can have it simpler later on. Okay. Plus, factor out again your x. That would be v squared plus 1 equals 0. So now this is a variable separable differential equation. So we multiply the whole equation by x squared again, because your x squared here is with the differential v. And we also multiply your v squared plus 1. So our resulting term, I would put a barrier here. Our resulting term would be v plus 1 over v squared plus 1 dv. And the other one is x over x squared dx equals 0. Integrate. So same process as we have on our previous one. I will separate your v over v squared plus 1 to have ln plus integral of dv over v squared plus 1. then plus, that would be dx over x equals integral of 0. And eventually, again, this would be the same. That would be 1/2 ln of v squared plus 1 plus, that would be arctan of v plus ln of x equals c. And eventually, we need to go back with our equation here, which is v is equal to y over x. And we have 1/2 ln of y squared over x squared plus 1 plus arctan of y over x plus ln of x equals c. Okay, so this is our another answer. And we proceed to our next example. Next, for number 4, we have x minus y dx plus x dy equals 0. So again, we check. This is 1, this is 1, and this is 1. So this is a homogeneous differential equation. Okay? So we check for the least complex. That would be dy. So it means we substitute y equals vx. And eventually, your dy would be v dx plus x dv. Okay, substitute, that would be x minus vx dx plus x v dx plus x dv equals 0. Distribute, that would be x dx minus vx dx plus vx dx plus x squared dv equals 0. So we check if there are terms that we could combine or eliminate. So these are the terms, no? And we are left with x dx minus x squared dv. Eventually, this differential equation is homogeneous. So it means, yes, homogeneous. But again, this differential equation is variable separable. So let's check for dx. We have x here. Yes, correct. For dv, okay, we only need the v as its variable and the coefficient. So it means we will divide x squared. Our resulting term would be x over x squared minus dv equals 0. And we integrate. Then we are left with dx over x minus integral of dv equals integral of 0. And eventually, our answer would be ln of x minus v equals c. But again, we substitute our v back. That would be v equals y over x. Okay? So our final answer would be ln of x minus y over x equals c. Okay? And for our last example, that would be number 5. We have x squared plus 2y squared dx over dy equals xy. So first, we convert this one into the form that we could identify for your homogeneous dE. So that would be x squared plus 2y squared dx equals xy dy. Then we transpose your differential of y to the other side. That would be xy dy equals 0. We check which of the following is least complex. So again, this would be dy. So it means we substitute y equals vx and dy equals v dx plus x dv. Substitute, that would be x squared plus 2v squared x squared dx minus x. That would be vx. Okay. Vx v dx plus x dv equals 0. Simplify, that would be x squared dx plus 2v squared x squared dx. So again, this term would be simplified to vx squared. Okay. Then we distribute that one here. So that would be minus v squared x squared and minus vx cubed dv equals 0. Then you check if there are terms that we could combine or eliminate. Yes, this one. So we are left with v squared x squared dx minus vx cubed dv equals 0. We group all the terms with dx. That would be x squared plus v squared x squared dx minus v x cubed dv equals 0. Then factor out your x squared. That would be, okay, I'll just put v squared first. V squared plus 1 dx minus vx cubed dv equals 0. So this the differential equation is now separable. Okay? So we divide the whole equation by first v squared plus 1 because it does not belong in our differential x. And for dv, we divide x cubed. Okay? So our resulting differential equation would be x squared over x cubed dx. Okay? Minus v over v squared plus 1 dv equals 0. Then we integrate. We are left with dx over x minus, okay, so this would be ln. Okay, so if we let our u to vv squared plus 1, we have du is equal to 2v dv. And your du over 2 would be v dv. Okay? And eventually, this would be du over 2 over u equals integral of 0. Then that would be ln of x minus 1 half ln of u, which is v squared plus 1 equals c. But again, we revert back to our original variables. So your v is equal to y squared or y over x. Okay? Substitute, that would be ln of x minus 1 half ln of y squared over x squared plus 1 equals c. So that is our final answer. So thank you so much and God bless.